So continuing on from with the lesson from page 8, looking at number 2. So I'll do number 2, and then I'll leave you to do number 3 on your own, because I think if I take you through number 2, it'll be a pretty, I don't want to say obvious how to handle number 3, but you'll be kind of geared up for it, moving in the right direction, as they say, whoever they are. So find the area of the region bounded by y equals the natural log of x, the x and y axes, and y equals 3 with respect to x or with respect to y. All right, so let's get a little sketcherooski going here. Gonna get some coordinate axes this time. X and y, poor quality y, there it is. The natural log of x, I mean, you could put this in your calculator, but the natural log of x has an x-intercept at 1. Keep meaning to play around with that setting. And is asymptotic with the y-axis, and then levels off, kind of like a curve being flattened. Levels off eventually. And there you go. Now, we also have to, well, we don't also have to do anything. We just have to find the area that's bounded between this function, the line y equals 3, which I'm going to put right now, and the two axes, which I'll use a highlighter to denote. I'm going to bring it down to 1.5, which I think was the lowest setting. So this is my bounded region. I want to be living only in between or within this enclosed area. All right. So it's a question of, how do I want to do this? Do I want to do it with respect to x? Meaning, do I want to use a dx in my integral, or do I want to do it with respect to y? All right. Now, we learned a couple lessons ago, forget which page, but when you get into bounded regions, you can handle it a couple of ways. One way would be to create a rectangle, find the area that you don't want, and subtract it off. That would be perfectly fine. But we also learned that if the entire region that you're interested in is bounded between a function and a particular axis, it is that particular axis that you should be integrating with respect to. All right. So in this case, if you look, you could see that we can get from the y-axis to the curve without interruption for the entire length of the range. All right, which goes from 0 to 3. So what I could do is find the antiderivative of some function x, right? Because it's going to, each one of these horizontal lines, the infinitesimal width rectangles, is going to have a thickness of dy, but a length of x. And the product of x and dy gives you the area of each one of those rectangles. So x dy. And y is the variable of interest, so we're going, in terms of y, from 0 to 3. All right, so I just got to get rid of this x in here. That's got to go. Fortunately, we have a relation that's pretty easy to convert over. Right, because y equals ln of x is the same as y equals log base e of x. And in exponential form, we get x is equal to e to the y. All right, so from 0 to 3, we have e to the y dy. Now this is a really, really nice integral, because the antiderivative of e to the y is e to the y. I don't even have to put that in the calculator, neither should you. All right, because we know our facts about exponential e. This is the nicest situation. All right, going from 0 to 3, so e to the third minus e to the 0th. So we're looking at a final answer of e to the third minus 1. And that's it. All right. Now, let's say you actually did want to do this a different way. All right. You're not required, in this case, you're not required to do it both ways. Right? It would kind of defeat the purpose. But I do want to show you what you'd be, the word's not, or the phrase anyway, is not up against, but it would just be different. So I'm going to say, or, and let me get rid of, oh good, I have it on the right setting for a change. Get rid of some of that. All right, it's going to be a little bit messy. Some things I can kind of get out of here, I think. Yeah. What can you do? Good enough. All right, so if I wanted to, what I could do is cordon off this rectangle here. That rectangle is going to have a length of 3, and we would need the length of its base. All right, so that horizontal line that gets you the base of that rectangle. That's going to happen when the natural log of x is equal to 3. All right, so because it's going to be some x value, comma 3 at that coordinate. So we would have to solve for x here. So we would take this system and write 3 equals ln of x. Pretty straightforward though, because again, ln is the same as log base e. So x is equal to e to the third power. All right, so we got that. That's not bad. All right, so hold that thought. Now we're going to find the area under this curve here, which just based off the nature of a logarithm, we know is intersecting at 1. But let's say you didn't know that. All right, which, you know, if I were in your position, maybe, yeah, definitely could not say that I would have known that off the top of my head. So I could say log base e, because again, that's the same as ln, would be equal to 0 of x, making x equal to e to the 0th power, which is 1. All right. So now what I could do to find the area under that curve, just that part of the curve, the null space that I didn't want, I can go from 1, I can go the x value from 1, and this is now a little misleading the way I drew it, so I'll just do it there. From 1 to e to the third of the natural log of x dx. So that'll give me the red shaded area, and we know that we have to subtract that from the area of the rectangle itself, which is going to be, again, we have an x value of e to the third and a y value of 3. Multiply them together, 3e to the third power. So that computation, which you would not be able to do by hand based off of the material that we've learned so far, x ln of x minus x is actually the antiderivative of the natural log of x, but we haven't covered integration by parts, so that's not something you would know how to do at this point. So what I could do instead is just go to the calculator, 3e to the third power, oops, do it again minus the oops. Easter egg, anybody, no oops this time. Tell me what movie that came from and you get a bonus point, if that's even a thing. X1, then e to the third. Making sure Making sure I typed it in right. Okay. 19 and change. Okay, so moment of truth. Is that the same as the other answer? All right, I'm a little nervous. Nice. Nice. So approximately 19.0855. Turns out retroactively that we know that this is the same as e to the third minus 1, but obviously one way you get the exact answer, the other way you get something not quite as exact. Well, it's not exact at all. Either way, I mean, it requires some mental gymnastics. You know, you got, let's just put it this way. In order to do it one way or the other, you do need to know some calculus. All right, so there's no getting around that. But I think if you kind of decide which way